Let us consider the following situation. We have three cubes of different colors. If we want to arrange these cubes in a line, then how many arrangements are possible? Here are all the possible arrangements of the cubes. Each arrangement shows a definite order. Thus, a permutation is an arrangement in a definite order of a number of objects, taken some or all at a time. Notation. The number of permutations of n things taken r at a time is denoted by the NPR. The letter P is an abbreviation of the word permutation. Now, let us understand the concept of permutations when all the objects are distinct. Let's prove the following theorem. The number of permutations of n different objects taken r at a time, where r is greater than 0 but less than or equal to n, and objects do not repeat is n minus 1, n minus 2, up to n minus r plus 1, which is denoted by NPR. Here's the proof. The number of permutations of n different objects taken r at a time is same as the number of ways of filling in r vacant places by n different objects. The first place can be filled in n ways. Once this has been done, the second place can be filled by any one of the remaining n minus 1 objects in n minus 1 ways. Similarly, the third place can be filled in n minus 2 ways, and so on. Continuing in this manner, the rth place can be filled in n minus r plus 1 different ways. Now, by using the fundamental principle of counting, we get the required result. Now let's understand factorial notation. The given notation represents the product of first n natural numbers as shown. We read this symbol as n factorial or factorial n. Here is an example. Remarks. Factorial n can be written as n into n minus 1 factorial. If we substitute n is equal to 1 in the above expression, then we get the following result, that is, factorial 0 is equal to 1. Students, try this puzzle. Use 5 zeros and any math operator to get the result 120. Here is the explanation. Add 0 factorial 5 times and again find the factorial of the obtained sum. On simplifying, we get the result as 120. Let us derive the formula for NPR. The number of permutations of n different objects taken r at a time is given as NPR is equal to factorial n upon factorial n minus r, where r is greater than or equal to 0 but less than or equal to n. Here is the proof of the formula. We have NPR is equal to n into n minus 1 into n minus 2 and so on up to n minus r minus 1. To convert it into factorial notation form, it can be written as follows. Hence, we get the result as factorial n upon factorial n minus r, where r is greater than or equal to 0, but less than or equal to n. Let us find the correct answer for the given question. A committee has 9 members. In how many ways can a president, vice president, and secretary be chosen from the members of this club? A. 501, B. 502, C. 503, or D. 504. Click to know the correct answer. Solution. Number of members in the club is equal to 9. We have to select 3 members out of 9. Substitute n is equal to 9 and r is equal to 3 in the following formula and solve it further. We get the result as 504. Hence, there are 504 possible ways in which a president, vice president, and a secretary can be chosen from the member of the club. Let's look at the following example. If we have 10 different pictures and want to choose 4 pictures to hang up on the wall, in how many ways can this be done? Solution. We have to choose 4 pictures out of 10 pictures. Therefore, by substituting n is equal to 10 and r is equal to 4 in the formula, we get the following result. Therefore, the total number of ways to choose 4 pictures out of 10 pictures is equal to 5040. Now let's prove the following theorem. The number of all permutations of n different objects taken all at a time is factorial n. Proof. We have n pr is equal to n into n minus 1 into n minus 2 and so on up to n minus r plus 1. Therefore, on substituting r equals n in this formula and simplifying it further, we get the result as factorial n. Observe the following example. How many different 6-letter words with or without meaning can be formed from the word flower? Here, repetition is not allowed. Solution. There are 6 different letters in the word flower. So, required number of words is factorial 6, that is 720. Here is another theorem. The number of permutations of n different objects taken are at a time, when repetition is allowed, is n raised to the power r. Let's prove this theorem. The number of permutations of n different objects taken all at a time is same as the number of ways of filling in n vacant places by the n different objects. Since repetition is allowed, therefore, all the places can be filled in n ways. Hence, by the fundamental principle of counting, the total number of permutations of n distinct objects, taken all at a time, where repetition is allowed, is n raised to the power r. Let's work out an example. Find the number of ways in which 4 prizes can be given away to 3 boys, when each boy is eligible for all the prizes. Solution. First prize can be given away to any one of the 3 boys in 3 ways. Similarly, other prizes can also be given away in 3 ways. Thus, the required number of ways is equal to 3 raised to the power 4, that is 81. Now, we will study the concept of permutations when all the objects are not distinct. Take 4 balls, out of which 3 are exactly same and 1 is different. If we arrange them in a line, then how many permutations are possible? Here are the all possible arrangements. Therefore, the required number of permutation is 4. If there are too many objects, then arrangement of these objects become complex. Therefore, to make this process easier, we will use the following theorem. Here's another theorem. The number of permutations of n objects, where p1 objects are of the first kind, p2 objects are of the second kind, pk objects are of the kth kind, and rest, if any, are all different is given as factorial n upon factorial p1 into factorial p2 up to factorial pk. Observe this example. How many different words can be formed by taking all the letters of the word institute? Solution. As we can see that there are 9 letters in the given word, out of which 2 are I's, 3 are T's, and rest all are different. Therefore, required number of words is equal to factorial 9 upon factorial 2 into factorial 3. Hence, total 30,240 words can be formed by taking all the letters of the word institute.